Welcome to this session. In the earlier session, we had seen the elementary concepts about the DBMS, like what is database, what is meant by database management system, what are its functions, how many data models are there, and what are the various data types we had seen in the earlier session. In this session, let us continue with the database structure or its database management structure of any relational database management system. Before going to start the session, let us see the components which comprises of the database management system. So, this is a kind of illustration wherein which each and every component is being shown, like the physical database, the storage manager, query preprocessor, the user level. So, here you can find the three levels of abstraction. One is the physical level, logical level, and the view level. So, in this way, depending upon the levels, we are going to identify what are the components and what are the functions of each and every component in that level. Let us see what are the various components in a database system structure. This particular database system structure comprises of a storage manager and a query processor. So, both these functional components comprises of the whole database management system structure. So, inside the storage manager there are various components, and the query processor also comprises of various components. So, in a storage manager, the primary function of it is a program module, it is a software that provides the interface between the low level data stored in the database and the application programs and queries submitted to the system. So, this storage manager acts as an interface between the low level and the high level, that is the application programs and the queries given by the user. So, this is a intermediary component between the user as well as the low level data. The storage manager is responsible for the interaction with the file manager also. So, it listens to the command given by the user, it interprets and it interacts with the file manager in order to retrieve the file from the physical database storage. The storage manager translates various DML statements given by the user into the low level file system commands. So, whenever we give the DML command, data manipulation language command, as it is not understood by the file system or else the file manager. So, it should be converted into low level file system commands. I can say a series of system commands. So, if at all there are several files associated with the database, there are many tables and we are retrieving from one or many tables. So, the DML command whatever we give will be understood first of all by the program module, the storage manager, and it conveys the same to the file manager in order to fetch the files. So, as it is the same statement whatever we give in English like language is not been the thing. It will be converted into a low level understandable system command which will be listened by the file manager. So, overall storage manager is responsible for storing, retrieving and updating the data in the database. Then comes the components of the storage manager. So, storage manager itself is not an individual component, it comprises of many other components which in itself each and every component has its task to do. One is the authorization and integrity manager, the transaction manager, file manager and the buffer manager. So, let us study one by one what is the role of authorization and integrity manager and the other components. So, this authorization and integrity manager, it is nothing but it verifies for the satisfaction of integrity constraints and checks the authority of user to access the data. So, just like whenever you are issued the privileges, So, each and every user may not get the equal privileges depending upon the role, depending upon the function, depending upon the designation. Each and every person may be awarded certain privileges. So, depending upon the password and the login name and the password, it verifies first of all whether the authorized user is using or not. So, that particular component, that particular check mechanism is being verified by the authorization and integrity manager. Once again, this is not a physical component, this is a kind of group of programs which verifies the authenticity of the user to access the data. So, obviously, whenever we create the database, centralized databases, one of the file that we create is the file that consists of these login names and the passwords. So, this authorization integrity manager verifies the credentials against that particular table and see what kind of rights are being provided and whether he is an authorized user or not. All these things will be taken care. Then comes the transaction manager. This is a crucial part in the storage manager component which ensures the database in a consistent state despite the system failure and concurrent transaction executions proceed without conflicting. So, the whole transaction part, suppose if you take care of any bank, if you take an example of a banking transaction, an insurance transaction, on any kind of transactions, suppose if there are some concurrent transactions on the same account, suppose I am withdrawing from my account as well as 2 days back I had given a check and at the same time the check also came to the bank wherein which they are about to release the money. So, it may be a kind of concurrent transaction wherein which both the transactions should be taken care at the same point of time and there should not be any kind of failure or any kind of error to be taken place. So, each and everything needs to be taken care by the transaction manager. Likewise, suppose if I had given a check as well as I am withdrawing the money from one of the ATM counters and that particular transaction may be happening concurrently. So, it should not conflict with the transactions, it should not stop either or of the transactions. So, both things should be happening and the failure should not take place. Then comes file manager. This file manager is a software program which manages the allocation of space or disk storage and the data structures used to represent information stored on the disk. So, the overall file management will be handled by the file manager. If at all a new database is created, it allocates the disk storage and within the database, suppose if new tables are being created, then once again the disk storage is being created, appropriate data structures, index files, everything will be maintained, everything will be managed by this file manager. The whole activity of the allocation management and then the disk storage management, everything is being handled by the file manager. Then comes the buffer manager. Suppose if the database is very huge, it may not fit into the main memory. The complete database never fits into the main memory. So, the database is residing in some disk storage. So, as and when the DML statements or the other statements are being issued by the user, it fetches from the disk storage and places the relevant information in the main memory to display or to give the users, to provide the users requirements. So, this particular responsibility is being handled by the buffer manager. It is a critical part of the DB system. Why? Because it enables the DB to handle various data sizes that are much larger than the size of the main memory. Just now the buffer manager had received a request to fetch some data of some 520 MB. Then immediately in the next query, it is asking for some another 520 MB and the main memory size is just 1 GB and within 1 GB the main memory has to see, the main memory will be having the operating system and other programs also. So, this particular remaining memory should be managed by the buffer manager depending upon the technique that it is using. So, this is a kind of critical management wherein which whenever the data size is larger than the main memory size, it should follow some sort of techniques, mechanisms, then it provides the requisite information. Then the data structures implemented by the storage manager. What are those? Let us see. Databases consists of the data files, index files and the data dictionary. So, for each and every aspect it should provide the data structure. So, the following are the data structures implemented by the storage manager. One is the data files, wherein which the complete values are stored in. The data dictionary. Data dictionary is nothing but data about the data. We can call that one as the metadata. The data files are storing the data, and about that particular data, whether they are primary keys and other things, those particular things needs to be taken care by another structure called as the data dictionary. Then indices part. Indices are created, index files are created to provide fast access to data items. Suppose if it is a random, if the DBMS is following random file organization technique, it should randomly pick the record whatever that the user requested for. So, it can't go sequentially one by one record till the end of the file. So, it follows a kind of index mechanism wherein which the primary key or the secondary key along with the pointer to the data file is being stored as an index file. So, these particular 3 data structures are to be implemented by the storage manager. Then comes the major component apart from the storage manager, which is called as the query processor. So, this particular query processor consists of a DDL interpreter, a DML compiler, query evaluation engine. DDL interpreter means data definition language interpreter, DML means data manipulation language compiler. You will be learning all these DDL statements, DML statements in the JUICE sessions. So, do not confuse, do not get panic. We are using these DDL and DML just to tell you that how this query processor handles these particular complicated things. So, the job of the DDL interpreter is it interprets the DDL statements and records the definitions in the data dictionary. Normally, there are 4 types of statements for any DBMS SQL language. One is the DDL, that is data definition language, the other is the DML, data manipulation language, the other is the TCL, transaction control language, and the last one is the DCL, data control language. So, DDL statements are normally used to define the database structure and the table structures. So, this it interprets the DDL statement given by the user and record the definitions, the schema in the data dictionary. So, then comes the DML compiler. It translates the DML statements given in the query language into an evaluation plan consisting of low level instructions and the query evaluation engine that the query evaluation engine understands. So, this compiler is nothing but an interface between the statement given and the conversion, converting and telling to the query evaluation engine that this is the kind of command given by the user, fetch the data from the storage. It also performs query optimization. It picks the lowest cost evaluation plan from among the alternatives existing. So, these 2 functionalities will be done by the DML compiler. One, it understands, it acts as an interface, it converts the DML statement into low level instructions, and then it performs the query optimization too. So, let us see what is query evaluation engine. This query evaluation engine executes low level instructions generated by the DML compiler. So, the user has given one DML statement just to update so and so record with so and so value. So, this particular command is DML command is given by the user, understood by the query processor, and thus the DML compiler translates the command given by the user into a series of low level instructions understood by the, just like system commands, to be understood by the file manager. So, the conversion will be taking place and will be executed by this query evaluation engine. And then the higher level, coming to the higher level or the view level, users exist. So, there are various kinds of users interacting with the DBMS. Some people may be called as application programmers, wherein which they directly interact with the system through DML calls. So, these people, they will be writing the application programs and they will be directly interacting with the system as an application program. So, this is one kind of user who will be interacting with the DBMS package. The other kind is the sophisticated users, those are analysts, and these people, they do not directly physically work with the databases. However, they form requests in a database query language. Suppose if some complicated queries are to be designed, these people will design and then those will be converted into the kind of interface with the help of a form, or else directly the query can also be placed against the command line. So, analysts directly do not interact with the DBMS with some sort of DML command or DDL command, however, they helps in forming the requests. Next set of users are specialized users. These specialized database application users they do not fit into the traditional data processing framework, however, they works on the specialized programs, specialized database application programs. And then the last set of users are the naive users like us, who invokes one of the permanent application program and have written those particular things which have been already written. We interact with those particular programs like web users. Suppose if I am involved in some e-commerce transaction, like I want to buy a mouse. So, I am using a website like amazon.in, I am logging into and I am using the category gadgets. I will go, I will move, I will watch what are the available brands and what are the offers that the Amazon is providing, and then I will follow on the transaction. Like there, my interaction is only a kind of naive user. I am not at all directly and talking to the database. However, the backend is working, the backend is showing as per my requirements, but I am not directly interacting with the database. Like the bank teller counters, clerical staff, agents, they do not know about the details of the backend database. However, they are allowed to use the database by having some sort of front end interfaces. So, they use the front end interfaces in order to fetch the data, in order to act onto the transactions. And then comes the most prominent person called as the database administrator. So, one of the reasons to use the DBMS is to have central control of the whole data. So, that is the greatest advantage that we are getting in whenever we are using this DBMS packages when compared to the file management, file processing packages. So, there should be a kind of centralized control. Here also, whenever we are using a DBMS package, a centralized control or else monitoring factor is required. So, what is stored, what kind of privileges should be given, how the database should be tuned, how the performance should be monitored, all these things will be looked after by a responsible person called as the database administrator, who has complete knowledge about the database management system that the organization is using. So, this person has the central control over the system. He can add a table, he can remove, he can set the privileges, he can verify the logs. So, these kind of top layer privileges are being provided to the database administrator. He is a responsible person for the efficient use of the databases, even for the failures also he has to take the responsibility. Let us see the functions of database administrator over here. One is the schema definition. So, the complete picture, the complete data, after understanding the requirements, he has to define the complete database schema along with the table structures and other things. Even he has to tell about the storage structure and the access methods definitions. Either the database is allowed to only access using sequential method, or else random access method is possible, and how the storage structures are being stored. Either it is a relational database management system, object oriented database management system, or else hierarchical management system, or else network management system. So, among the things those are available, he has to specify, he will fix the storage structures as well as the access method definitions. Then comes the schema and physical organization modification. Suppose if he wants to disturb the schema, he wants to modify the schema of a table or else the database itself, he will do it. No other person is being granted that privilege in order to disturb the schema. And also the physical organization modifications. Sometimes they may give some sort of organization definitions or methods he will set, and sometimes he may be restricting to only certain access methods. So, this is the one of the critical function of the DBA. Then granting of authorization for data access. Suppose if an employee is joined today, so he will set the granting of authorization. So, what he is at so and so level, so he will be authorized with so and so grants on the database, or else some sort of views will be created to that particular user, and only those views will be provided as the privileges to that user. So, it is the function of the database administrator. Or else suppose if a person is promoted from so and so designation to the next designation and the privileges are increased. So, accordingly he has to set the privileges and grant the authorization to the database access. Then comes the routine maintenance. In the routine maintenance, backup is the major thing. So, the complete server database backup needs to be taken periodically, and he has to do this function as well. And then the disk space management. From time to time he has to manage the disk. So, depending upon the disk organization technique or the file organization techniques that the DBMS is using, the disk space is being completely distributed and randomly and completely distributed. So, sometimes he has to run certain tools in order to manage the disk space management, like we do in the PCs. There is a software for the disk space, which is a simple tool is there in the accessories, wherein which we use that tool in order to manage our personal hard disk on the system. And also monitoring of performance of the system. Whenever sometimes due to some operations the performance of the database degrades. So, he has to monitor the performance and then he has to tune accordingly, that is called as tuning of database. So, depending upon the performance he has to tune the databases also. And then this is the holistic diagram, once again I am presenting here. This is the illustration. We had seen the disk storage at this physical level, and then the storage manager and the query manager as well as the users, different kinds of users. Hope I think that you had understood all the components of the this particular database management system. And then let us move how many types of architectures are available. Then there are two types of architectures available. One is the 2-tier architecture and another is the 3-tier architecture. So, whatever the architecture may be, there will be a set of client machines wherein which the users remotely working with the databases, and then there are some server machines wherein which the database is resided. So, the client and the server, these are the main components of the architecture. How these particular clients and servers are being placed, this is how we partition into 2-tier architecture or else 3-tier architecture. Just go through this particular illustration here. This is the illustration. So, here you have 2 tiers. One is in the 2-tier architecture, this is the client part wherein which the user is interacting with the application. Through the network, the database system, the server is connected. So, this is the client part and this is the server part. Here you can see only 2 tiers. One is the client side tier and the other is the server side. This is the database. So, front end and then back end. So, this kind of architecture is called as the 2-tier architecture. The user interacts with the application on the client part and then the database is stored far away in the form of in some server, and through the network connection we are able to access the database. And in the 3-tier architecture, you have one other component called as the application server. This application server is nothing but it consists of the business logic. It does not have any application client program over here. We interacts with the business logic and it provides the interaction with the database system. And this is the basic difference. Here one of the tier is being increased in the name of a business logic. Depending upon the business logic or depending upon the conditions provided, that particular database, part of the database management system is being retrieved. So, here directly it is connected to the database, but here with the help of some sort of interface called as the business logic, it is being connected to the back end. So, this is the basic difference between 2-tier and then the 3-tier architecture. So, before concluding this session, let us have a recap. In this session we had seen the components of a database structure, the storage manager and the query processor. And then we had seen 2 types of architectures, one is the 2-tier architecture and then the 3-tier architecture. Thank you.